Welcome back, everyone. Today, we are going to do a really cool deep dive into the world of scientific computing with Python.
Yeah, it's going to be a good one.
It is, it really is. We're focusing on SciPy. So SciPy it's basically this incredibly powerful Python library, and it lets you do all sorts of really amazing scientific and technical computing. It builds on top of NumPy, which a lot of you probably already know and love.
Okay.
If you don't know it yet, don't worry, we're not going to get super deep in the weeds of NumPy, but just know that SciPy kind of takes things to that next level. It gives you all these tools for like advanced math, optimization, signal processing, all that really cool stuff. Now, the source material we're using today is actually a fantastic academic paper, simply titled SciPy. Scientific Computing in Python. It's a really great resource. I highly recommend you check it out if you want to learn more. It really lays the foundation, and is what we are going to use to kind of guide our conversation today.
Perfect.
So whether you're, getting ready for a big technical meeting at work, or just kind of want to brush up on your Python skills, or even if you're just someone who's like super curious about how computers are actually used to solve all these crazy complex scientific problems that we face, well, you've come to the right place.
Exactly.
So let's jump right in.
Yeah, let's do it.
So first things first, let's break down what SciPy actually does.
Okay, sure.
Can you give us like the quick and dirty, like what kind of problems can this thing actually solve? What is it good at?
So SciPy is like a toolbox.
Okay.
It's like a toolbox that's specifically designed for scientists and engineers who are working with Python. So it's got all these specialized tools that can do really amazing things. For example, imagine you need to solve a system of equations.
Okay.
Now, this could be something related to maybe designing a bridge and understanding like the forces that are at play, or even like analyzing chemical reactions. SciPy can actually help you find solutions to these systems of equations.
Wow.
It uses linear algebra tools. There's a specific function in SciPy called linealj.solve, and it's incredibly powerful.
Okay, so break that down. Like, what is lineal.solve doing behind the scenes?
Yeah, so linear algebra stands for linear algebra.
Okay.
And linear algebra is essentially this branch of mathematics that deals with systems of linear equations, matrices, vectors. It's a pretty fascinating field. Now, the solve function is specifically designed to find the solutions to these systems of equations.
Got it.
So you give it the coefficients of the equations, like in matrix form, and it'll spit out the values of the variables that satisfy all the equations.
Okay.
It's actually pretty cool. And the paper gives an example of how you can use this to solve for the forces acting on different parts of a bridge.
Okay.
Based on its design and how much weight it needs to carry. So you could essentially use SciPy to make sure that a bridge is going to stand up.
That's actually really cool. I mean, we're talking about like real world physics problems here.
Exactly.
But, couldn't something like Excel, like a simple spreadsheet, couldn't that do that sort of calculation as well?
You're right. Simple spreadsheets can handle basic equations. But what if you have hundreds, thousands, or even millions of variables? Excel's going to choke. SciPy's built for that.
Yeah.
It can handle that scale and that complexity. Plus, you can integrate it with other Python tools for tasks like, creating really cool data visualizations, or even like machine learning.
Okay. So it's that integration with all the other Python stuff.
Yeah.
That's where SciPy really shines, especially with those large data sets. Now, the paper also mentioned optimization as like a major thing that SciPy is good at, but that sounds a little abstract. What exactly does optimization mean in this context?
Yeah, so optimization is basically all about finding like the best possible solution, like the best solution out of a whole bunch of potential solutions.
Okay.
And it has a lot of real-world applications.
Okay, like what?
Let's say you're a company that needs to plan like the most efficient delivery routes for your fleet of trucks.
Okay, so you got all these trucks going all over the place.
Exactly. You need to think about things like distance, traffic, fuel costs, delivery time windows, and even like driver breaks and all that stuff. It gets very complicated very quickly.
Yeah.
SciPy's optimization tools, though, can actually analyze all those variables and crunch all those numbers and figure out the solution that is going to minimize your costs and maximize your efficiency.
Okay, so instead of having a person sitting there and with a map and little pins trying to figure this out over days and days and days, SciPy can just do that automatically.
Yeah.
Like really quickly.
Exactly. And that's just one example. Optimization is used in finance. It's used in manufacturing. It's even used to train AI models.
Wow.
And SciPy gives you the tools to do all that right within Python.
That is really cool. Now, signal processing was also listed as a major strength of SciPy in the paper.
Yes.
what exactly does signal processing even mean?
So signal processing is all about manipulating and analyzing signals. And signals can be anything. It can be sound waves, it could be stock market prices, it could be anything that changes over time.
Yeah.
SciPy gives you the tools to filter out noise from a signal, extract meaningful features, or even synthesize entirely new signals based on your data.
Wow. Okay, so give us a real-world example here.
Okay, so think about noise-canceling headphones.
Okay.
You
Yeah.
know how they magically block out all the annoying sounds around you? They use signal processing to do that.
Uh-huh.
They're constantly analyzing the incoming sound waves, identifying the unwanted noise, and then they generate an opposite signal to basically cancel it out. It's pretty cool.
That is really cool. So it's not just about math equations then. We're
Right.
talking about understanding patterns and data over time.
Exactly, and the applications are vast.
Like what else can you use this for?
In medical imaging, SciPy's signal processing tools can help doctors identify tumors or abnormalities in scans.
Hmm.
Yeah, and in telecommunications, it's used to improve the clarity of phone calls and enhance audio quality for streaming services.
That's incredible. So basically, SciPy is working behind the scenes to improve, like, all of our lives.
In a lot of ways.
Had no idea.
Yeah.
That's amazing. Okay, so we've covered a lot of ground here, but before we wrap up, what's like the one big takeaway that you really want our listeners to remember about SciPy?
Okay, the key takeaway for me is that SciPy gives you the power to tackle these really complex scientific and engineering problems using the flexibility and the power of Python.
Mhm.
If you're working with data and you need to perform like advanced calculations or do some optimization or, do signal processing, SciPy is the tool for the job.
Absolutely. It's an invaluable tool to have in your arsenal. I think you've explained it perfectly.
Great.
So for our listeners out there, as you go about your day, just keep an ear out, or I guess keep an eye out, or, just think about it. You might be surprised by how often the magic of SciPy is actually working behind the scenes. Like you said, it's in our phones, it's in the traffic updates we get on our way to work. It's everywhere.
It's everywhere.
So thank you so much for joining us today.
It was a pleasure being here.
And for everyone listening, don't forget to check out the show notes for more information about SciPy, including a link to that paper that we talked about.
Yeah, definitely check it out.
Until next time, happy coding.
Bye, everyone.